So this week in class we started to look at some questions. This is the worksheet from class that are combination questions. So they are combining all three of our index laws. Some questions will have 2 index laws, some will have 3 index laws, but the questions are becoming more complicated because in week 1 of the term we learnt the 3 index laws in isolation and practiced them by themselves, but we now are being presented with questions that have more than 1 index law to work through. This top question's already been done for us. I have a numerator, r to the power of 6, multiplied by r to the power of 2, divided by r to the power of 3, multiplied by r to the power of 4. So let's work through the numerator first. Remember, we keep the base. The base is r. So I've written the base here. And when we multiply, the rule is to keep the base, which is r, and add the powers. This is how we get r8, because 6 plus 2 equals 8. Now here is our denominator. We keep the base, which is r, and we add our powers of 3 and 4 to give us 7. Okay, so now we've worked out our multiplications. Now we're left with r to the power of 8 divided by r to the power of 7. When it's a division, we keep the base, which is still r, but we subtract the powers. So 8 take away 7 gives us 1. So r to the power of 1 in its most simplest form is r. This is our final answer. The next question, we have some coefficients. These are these numbers here, our 18 and our 9, which sit alongside our variables or bases and our powers or our indices. So let's work out, we have 18 divided by 9 if we just focus on our coefficients. 18 divided by 9 is 2. 2. Now we have 2 bases in this question, or 2 variables. So again we're going to keep our bases of m and n. We have m to the power of 3 divided by m, which we really know is m to the power of 1. So we say 3 take away 1 because it's a division, so it's index law 2 happening here. 3 take away 1, we have m to the power of 2 left. We have m to the power of 4 divided by m to the power of 2. So we keep the base and we subtract the powers. So 4 take away 2 is 2. This is our answer. Keep the base, keep the base, subtract the powers in this question because it's a division. Question 3. Okay, question 3 and question 4, very similar because I have this idea of to the power of 0. So during the week in class we learnt that anything to the power of 0 is 1. Anything to the power of 0 is 1. These brackets are really important here because it's making this expression in here one package. NA, we don't know what A is, we don't care what A is, but N, whatever A is to the power of 3, the brackets are extremely powerful in this question. It means the whole expression is collected together. So whatever is in this parcel here, because of the brackets, is to the power of 0. Which means anything to the power of 0 is 1. There's no working out. Thinking involved. The brackets were there, very powerful. Anything inside those brackets gets grouped together. Okay, so we could give A a value and actually work out what this is. We could say A had a value of 2. Okay, we could say A had a value of 2. So that would become in brackets 9 times 2 times 2 times 2, all to the power of 0. So we say 2 times 2 is 4 times 2 is 8. 8 times our 9 is 72 to the power of 0. It doesn't matter what A is. because it's going to give us any value to the power of 0 is 1. Anything to the power of 0 is 1. Okay, but the brackets are really important because it made us group it all together. And it didn't actually matter what the value of A was. It could have been 10, could have been 11, it could have been 3, and then it would have given us a value here, a digit here to work with. But at the end of the day, it was to the power of 0. So anything to the power of 0 was 1. Whereas this question up here is a little bit different. There's no bracket around it. So this is really saying n times a to the 0. Very different to the other question, because now we have our 9 and we're saying, well, this here, a could be 100, a could be 1,000, a could be 3. Anything to the power of 0 is 1, but this time with no brackets the 9 is carried down because it was just a to the power of 0. Anything to the power of 0 is 1. Okay, question 5. Here is index law 3. So something to the power of 0 that isn't index law 3. This here is our index law 3 when it's a power to a power. We keep the base, we multiply the indices. Keep the base, multiply the indices. 6 3s are 18, multiplied by 4m. So this is index law 3. Now I can see a multiply, it's index law 1 that's being applied. My coefficients should always sit at the front of an expression, so we bring our 4 to the front. Now we have m18 and an m. So we're back to index law 1 where we keep the base and add the indices. We've got m18 and another m, which really is m to the power of 1. 18 plus 1 gives me my m to the 19. This here is my final answer. 4 m to the power of 19. Index law 3, index law 1. Question 6. Okay, we have index law 1 happening in our numerator and our denominator. And then we have index law 2 with our division. Let's simplify these expressions in the numerator and the expression in the denominator. Let's work out our coefficients. 2 times 3 is 6, times 4, 24. Index law 1 says to keep the base, add the powers. So C2 and 3, 2 plus 3 is 5 because it's index law 1, 2 plus 3 is 5, plus another one is 6, divided by 6 4s are 24. C is our base, keep the base, add the powers because it's a multiply, index law 1. 3 and 2 is 5. Okay, now I have 24 and 24 on the top and bottom. They're our coefficients. 24 divided by 24 is 1. C to the 6 divided by C to the 5, like 24 divided by 24 gave us 1. C to the 6 divided by C to the 5. So I have the same base and I keep it. This time I go C to the 6, 6 take away 5 is 1. So really, this is 1 times C. Our simplest answer is C. This here is correct, but this here is the most simplified because it's really saying 1 times C to the first power. Okay, we don't have to put this one here. When we go 6 take away 5, it is 1, but C to the 1, we don't normally write the 1, so you can ignore it. But 1 times C is just going to give us C. Question 7. Little star on here. A little bit trickier looking. Just do one thing at a time. Let's leave W to the cubed. But let's look here. We've got this idea of anything to the power of 0 is 1. Okay, we cannot simplify that. W cubed we can't simplify. We don't know what W is, so we have to leave it. But we can simplify this. Y to the 0, anything to the 0 gives us 1 multiplied by Z. And all of that's to the power of 4. Okay, let's rearrange our brackets, because in class we always see our coefficients first and then we put our things in alphabetical order. Okay, so now we can see some of, we can put a 1 there. We can see that we have a power to a power. Really, we can ignore our 1 or discard our 1 from here, but we have 1 W. This is index law 3. Keep the base, multiply the powers. Keep the base, multiply the powers. 1 times 4 is 4. Probably don't put that bracket there because we're trying to get rid of the brackets. So the 1 can come through. It's eventually going to disappear because 1 doesn't have an impact on the value of things, does it? 1 times something. But we've simplified this now to W to the 12th, because we kept the base and we multiplied our powers with index law 3. Kept the base, multiplied the powers with index law 3. So this here is our answer. Okay, on the back it says simplify to prove that this equals 1. Okay, it will equal 1. Let's look at our numerator first, please. Let's have a look here and identify that it's index law 3 happening. Keep the base, multiply the powers, times B7 times B3. We'll work through that soon, but I can see index law 3 happening here. So B 6 3s are 18. Okay, let's simplify. B18 is as simple as it's going to get on the denominator. Sorry, put the denominator down, but now I can keep the base. It's index law 1 happening here. 8 plus 7 is 15. 8 plus 7 is 15, plus 3 gives us 18. Okay, so this is where some students might get confused, because you're in the idea of cancelling things out. You cancel out, not that it equals 0, but because it equals 1. And when we multiply things by 1, it doesn't have an impact. So once we cross them out, we kind of forget about them, because they've kind of run away together. But we haven't crossed them out, meaning that they mean 0. We actually cross them out because it's like B18 divided by B18 is 1. It's like anything. If it's just 18, 18 divided by 18 is 1. 100 divided by 100 is 1. Anything divided by itself gives a value of 1. So when you do this crossing out in your maths, it's not that that's incorrect. But some students think that the cancelling out means it's gone to 0. Okay, but the cancelling out is just you saying, well, anything divide itself actually gives a value of 1, which then multiplying through doesn't have an impact. So it does kind of disappear. But the value of B18 divided by B18 is 1. Just like 100 divided by 100 is 1. Or 50 divided by 50 is 1. So 1 is our answer. We have proven that it equals 1. Have a go at making up your own question. I think you are asked to make up some questions in your test. So have a go at applying these ideas with your own creations. Okay, so now what do I do? Review.